Hi, so for today we will be continuing our discussion all about the super mesh analysis, and this will be a part 2 of our discussion all about the super mesh. And for this video we will be solving one problem only, but this problem involves 4 mesh currents. So we would be expecting that this would be somewhat a hard problem. Okay, so we are given this kind of circuit wherein we know that we have 4 mesh currents here: I1, I2, I3, and I4. But we know that we will be having a mesh or a super mesh if in between the 2 mesh currents we have a current source. So in the case of I1 and I2, we have 5 amperes. And of course, in the case of I2 and I3, we have another dependent current source, okay, which is 3I sub O dependent on the current here. So such cases, we will be treating this circuit as if we are going to remove 5 amperes, we are going to remove this 3I sub O and perform still a KVL, okay, on this 3 meshes. Okay, it is as if as we are going to remove this and write the equations, okay, by mesh I sub 1, mesh I sub 2, and mesh I sub 3, just like what we did on our previous video. So what will I do is to simply, again, just like what I've said, if we are to remove those circuits, okay, or those elements, current sources. So we will be having a circuit that would look like this, okay? Wherein we have the values of, I forgot the other one. So we have still 2 ohms here and we have a 10 voltage source here, okay? That will be our circuit, wherein we have 6 ohms here, then we have 2 ohms here. This is our 4 ohms. This would be our 8 ohms. And this would be our 2 ohms. This would be 10 volts here. Okay? So what are we going to do is, still we have still the mesh current 1 here, I sub 1. And we know that what uh, flows on 6 ohms is the mesh current 2. And we know that what flows with the 4 ohm and 8 ohm, we still have the mesh I sub 3. So what are we going to do is, we put the mesh equation. So we have the KVL at super mesh. Okay. And don't also forget that we have another mesh current here, which is not involved in the super mesh. So we have to have what? We start with mesh 1. So we have mesh current 1. So it has 2 I sub 1. Okay. Then we move here by KVL. So we have plus 4 I sub 3 here, because this 4 ohms is not shared by any mesh current. So we have plus 8. This 8 ohms is shared by I sub 3 and I sub 4. So therefore, we have I sub 3 minus I sub 4. 8 quantity I sub 3 minus I sub 4. Okay. So, and then lastly, we have the 6 ohms, which is 6 I sub 2. And that is equal to 0. So we are going to simplify. We have 2 I sub 1 plus 4 I sub 3 plus 8 I sub 3 minus 8 I sub 4. We only distributed the values. 6 I sub 2 equals 0. So simplify. We have 2 I sub 1. We have plus 6 I sub 2. I'll be writing this I sub 1, I sub 2, okay, in sort of that number so that we will not be confused. And then we have 4 I sub 3 plus 8. We have 12 I sub 3. 12 I sub 3. And then we have minus 8 I sub 4 equals 0. So if we divide both sides of the equation, or to simplify this by 2, so we'll be having our equation 1. We have I sub 1 plus 3 I sub 2 plus 6 I sub 3 minus 4 I sub 4 equals 0. And this will be our first equation. Now, we have 4 mesh currents. So therefore, we need to have 4 equations. 4 unknowns, 4 equations. So, and another one, okay? So, as I have said on the previous video, when we are dealing with super mesh, we perform KVL as well as the KCL. and we are given a KCL, one KCL at point P or node P, and one KCL at node Q, because we have to include this source in between our meshes, okay, in order to come up with another equation. So if we wish to have KCL at point P, point or node P, okay, node P. So what will happen is that we have uh, current entering positive, we have I sub 2. Current leaving will be negative minus I sub 1 minus 5. This is the 5 amperes. That is the dependent source. Okay, independent current source, I mean. So, rearranging, we have I sub 2 equals I sub 1 plus 5. Okay, and that is our second equation. Okay, so but I will arrange this, okay, as I've said a while ago, I will arrange it, okay, by I sub 1, I sub 2, and I sub 3. So we have negative I sub 1 plus I sub 2 minus 5 equals 0, so that we are consistent. So this is our second equation. How about if we have a KCL at point or node, should I say node? Okay, I'll change this as node. That's the proper term. KCL at node P, KCL at node Q. Okay. So we have a KCL at node Q. So we have to, again, write the equation. Current entering would be positive. That would be I sub 3 minus we have I sub 2. Okay. Because it's going away with the node. And entering the node is 3 I sub O equals 0. Okay, but I sub O, okay, is equal to the negative of I sub 4. As you can see, I sub 4, mesh current I sub 4 is in this direction. So that I sub O is actually on the opposite direction. So I sub O would be equal to negative I sub 4. Okay, so I hope that is clear. So we will be changing this as plus 3. We have negative I sub 4 here equals 0. Okay, so now we do have negative I sub 2 plus I sub 3 minus we have negative 3 I sub 4 equals 0. So that is our third equation. So still I sub 2, I sub 3, and I sub 4. Okay, so how about the fourth equation? KVL at this loop. Okay, fourth loop. Okay, for our mesh current I sub 4, we have to have a KVL for that. Mesh 4 or loop 4. So we'll be having what? 8. This 8 ohms is shared by I sub 3 and I sub 4. It so happened that we are now on the process of writing the equation for I sub 4. So this would be I sub 4 minus sharing with the mesh current 3 minus I sub 3. And then plus we have 2 I sub 4. That is purely on the mesh 4 or loop 4. And then we have plus 10 volts equals 0. So simplifying, we have 8 I sub 4 minus 8 I sub 3 plus 2 I sub 4 equals negative 10. So I would transpose the constant on the right side. So we have 8 I sub 4 plus 2 I sub 4, that's 10 I sub 4 minus 8 I sub 3 equals negative 10. So if we divide this by 2, we will be simplifying this. It's always good to simplify this. Okay, so we have 5 I sub 4 minus 4 I sub 3 equals negative 5. And of course, we have negative 4 I sub 3, rearranging this, plus 5 I sub 4 equals negative 5. And this would be our fourth equation. So that's the end of circuit parts. Okay, circuit part. What are we going to do now is we are now going to solve these four mesh currents by mathematics. And what I would like to use is always the Cramer's rule. Okay? So again, if I'm going to write all of the equations, okay, so for our equation 1, we have I sub 1 plus 3 I sub 2 plus 6 I sub 3 minus 4 I sub 4 equals 0. That is first equation. Our second equation is negative I sub 1 plus I sub 2, okay, equals, we have, I could transpose this on the right side, the constant, so that it becomes 5 here, okay. Okay, so we have transposed that 5. So on the right side of the equation for our second equation, so that it becomes positive 5 here. And then for our equation 3, we have negative I sub 2 plus I sub 3. We have negative 3 I sub 4 equals 0. And lastly, we have this number 3 equation. So we have negative 4 I sub 3, and then we have plus 5 I sub 4 equals the negative 5. Okay, so finally, we are going to write this in our matrix. So the coefficients of each equations, okay, for I1, I2, and I3. So for I1, we have 1, negative 1, okay, and 0, 0 for the equations 3 and 4. How about for I sub 2? We have 3, then we have positive 1, we have negative 1, okay, and we have 0 for the equation 4. And of course, what will happen for I sub 3? So we have 6 I sub 3. For the second one, we don't have, so it's 0. For the third equation, we have 1. The constants, okay, of each equation. Then for fourth equation, we have negative 4. For the I sub 4, we have negative 4 for equation 1, 0 for equation 2, and negative 3 for equation 3, and we have lastly 5 for I sub 4. Then we have here we have I sub 1, I sub 2, I sub 3, I sub 4, and that is should be equivalent to the constants. So we have 0, 5, 0, and negative 5. So what are we going to do is to get the determinant of this 4 by 4, I'll have to use the cofactor method. So I'll be choosing the row which has many zeros. Okay, so that our computation would be easy. So we have a rule. If we choose this as our cofactor, for example, okay, we have the sign convention. So we have for the first row, we have, this would be positive, negative, positive, negative. Okay? So, positive, negative, positive, negative. At least for row 1. If you choose this whole entire column 1, no problem, but you will be having a hard time solving it. So, but if you choose this row 1 or this column 2, okay, so your life or your computation would be much easier. Okay, again, we have a sign convention. Remember, in matrix, okay? So, we'll have positive, negative, positive, negative with the cofactor, and this would be negative, positive, negative, positive, and so on and so forth. This would be again positive and positive, negative, and this would be negative. So, our signs would be positive here. For since we choose the row 1, we have negative here, we have positive here, and we have negative. So, I just only showed you the pattern of signs when we are doing cofactor methods. Okay? So I erase some number. Okay? What is that number up? For the 6, we have a 0 here. 6, 6, 0, 1, negative 4. Okay. So, what I'm going to do is that I'll choose the row 1. Okay? And for each element, I'll be having what? 1, the positive 1 multiplied by the determinant, okay, of the remaining matrix if I'm going to what? If I'm going to uh, exclude row 1 and column 1 because this is my row 1 and column 1. So, I will be having the determinant of this. So, I'll have 1, negative 1, 0, 0, 0. We have 1, negative 3, and we have negative 4 here and 5. So again, I have the pivot element of 1. I have a positive sign plus 1. Okay, that is multiplied by the 1. So doesn't matter, still 1. And since I get the pivot element row 1, column 1, I'll be going to exclude all the elements containing row 1, okay, and all the elements containing this column 1. Okay? So we will be having this determinant. And that is minus, because of this minus of the negative 1 multiplied, okay, because this is the negative 1, I've chosen this part, okay. So the next thing that we are going to do now is get the determinant excluding this element. So because this element is in row 1, okay, row 1, I mean this is row 1. So this negative 1 is actually in row 2, column 1, so that I'll have to exclude all the row elements in row 2 and column 1. Sorry, this is columns and this is rows, okay? So we have the row 2, column 1, and then the remaining elements, we get the determinant 3, 6, negative 4. And then we have negative 1 here, 1, negative 3, and 0, negative 4, 5. Okay? Again, plus 0 and the determinant of the remaining. Since this is now multiplied by the 0, okay, if we choose this column 1. Sorry, we choose the column 1, not the row 1. Because the row 1 is this. Column 1, this is the column 1. So, if we choose this, okay, the column 1, okay, we will be excluding all the elements in the row 3 and the column 1. Since this is already 0, any number multiplied by the determinant of the remaining, since this is 0, we have a 0. So, and then another one minus 0 because of this 1 in our last element of for column 1. So, we'll be having excluding this and get the determinant of this, but this is multiplied to 0, so that is still 0. So again, we have chosen, okay, as our pivot element the column 1 because it has many zeros. You can also choose row 2 because it has 2 zeros. So if we wish to calculate this, so we'll be having 1 multiplied by the determinant of this. So let's try to solve that in our calculator. So we have shift matrix, dimension of matrix A, 3 by 3. So we have 1, we have 0, we have 0. Although you can do this manually, okay, but I would trust my calculator more, okay. And then we have 5. So we have that AC, that matrix A was already stored. So we have determinant of the matrix A. So we have negative 7. So this becomes negative 7. Negative times negative, this becomes plus 1 multiplied by the determinant of this one. So we'll be having what? Again, matrix, uh, shift matrix, dimension of the matrix A. So we have 3, 6, 4. We have negative 1. We have 1. Okay, negative 1, 1, and negative 3. We have 0, negative 4, and 5. Okay, so we store that. Simply press AC and then we have shift matrix determinant 7. Okay, shift matrix of 3. So matrix A. So that is technically equal to what? We have 25. And of course, if we wish to calculate the determinant of this, okay, so what will we have is matrix, shift matrix. We have dimensions of matrix A. We input the values. We have 3, 6. We have negative 4. Okay, negative 1. Then we have 1. we have negative 3, we have 0, negative 4, and 5. So double check 3, negative 1, 0, and then 6, 1, negative 4. We have negative 4, negative 3, and 5. So AC, shift, matrix, determinant 7, shift matrix of A, matrix of A, matrix A, 3. So Viola, we have a value of negative 7. So this would be negative 7 minus 7. This would be negative 14. So this would be the value of our delta. Okay? So this is our delta. Okay, so we already got the negative 14. So what will we do? Again, if we wish to get I sub 1, okay, for I sub 1 solution, we are simply going to replace this first column with our constant and get the determinant. So we have 0, 5, 0. And so again, we will be replacing the first column with the constant if we wish to get the I sub 1. So we have 0, 5, 0, and negative 5 here. And then we copy the remaining elements in our matrix. So we have 3, 1, negative 1, and we have 0. We have 6, 0, 1, negative 4. Then we have negative 4, 0, negative 3, and then we have 5. Okay? And then I'll be choosing again this first column as my cofactor because it has many zeros in it. So our computation will be somewhat easier. So we have sign convention plus, minus, plus, minus. Okay, so that we have for our first row 1, column 1, we have 0, positive 0. Okay, and then multiplied by the determinant. Okay, excluding the elements in row 1 and column 1. So this will be, but since this would be 0 multiplied to 0, so it would be 0. So minus, we have 5. Okay, and then the determinant covering this portion. So we have 3, 6, negative 4. Then we have negative 1, 1, negative 3. And then we have uh, 0, negative 4, and 5. Okay? And then we have plus 0 again. So any number multiplied by 0 would be 0. And then minus, we have the negative 5 for our row 4, column 1. Okay? That element, negative 5. So what are we going to do is to simply exclude all the elements, okay, including in the row or column 1 and then the row 4. Okay, so all of the elements in this negative 5, all of its column and its row. So we are left with 3, 6, negative 4. Then we have 1, 0, 0. Then we have negative 1, 1, negative 3. So that if we are going to compute that using our calculator again, so we have matrix, okay, dimension A, matrix A. So we have 3, 6, negative 4 here, and then negative 1, 1, negative 3, 0, negative 4, and 5. So if we get the matrix determinant of that, so we have matrix A, so we have negative 7. So this would be negative 5 times negative 7. Okay, and negative times negative would be plus 5 here. And then the determinant of this, we shall compute, okay, again in our calculator. So we have the matrix dimension, matrix A, or you can choose matrix B, 3, 6, negative 4. So 1, 0, and then 0. Then we have negative 1, and then 1, and then negative 3. So AC, then shift matrix determinant, shift, matrix A, determinant of matrix A, that is 14. This is now 14. So we have 35 plus 5 times 14. We calculate that. So if we calculate that, we have 35 plus 5 times 14. So we have 105 as our, this would be our delta sub 1. So to get I sub 1 using the same formula, so we have, I told you we have I sub 1 should be delta sub 1 all over delta, of which our delta sub 1 would be 105 all over delta, which is negative 14, and the answer should be negative 7.5 amperes. Viola, we already got I sub 1. Still, we have 3 more unknowns to go. Okay? But for I sub 2, okay, we can compute it using equation 2, from equation 2. Our equation 2, again, will be, is equal to, we have I sub negative, I think, if we rearrange our equation 2, okay, such that we isolate I sub 2, so we have I sub 2 equals I sub 1 plus 5. So our I sub 2 would be, I sub 1 is negative 7.5 amperes plus, this is still 5 amperes. Okay, because it's a current source. So we have negative 2.5 amperes. So now to calculate the other I sub 3 or I sub 4, so we will be using equation from equation 3 and 4. We will substitute the values. So we have negative I sub 2 plus 3 I sub 3. Okay, so this is I sub 3. So we have I sub 3, and then we have 3 I sub 4 equals 0. And then for the equation 4, we have negative 4 I sub 3 plus 5 I sub 4 equals negative 5. But we know that I sub 2 is now equal to negative 2.5. So take careful note of the negative here. So this is negative I sub 2. This one, equation 3. So we have the negative of the negative 2.5. So this becomes positive 2.5, and I transpose it to the right side. So that becomes negative I sub 3 minus 3 I sub 4. So this again becomes negative. Positive times positive 2.5. Transpose it. So this becomes negative 2.5. And then we have negative 4 I sub 3 plus 5 I sub 4 equals negative 5. So I will be multiplying the equations, okay, the equation 3 by 4, so that by doing that and adding this to our equation 4, so what will happen is that we have 4 I sub 3 minus 3 I sub 4 equals negative 10, and plus, okay, I'll be adding this, so elimination. So this would be negative 4 I sub 3 plus, sorry, so we have to multiply also this should be 12. 4 times negative, negative 12. So this would be 5 I sub 4 equals negative 5. So we add them. We know that these two values would cancel. So we are now left with negative 7 I sub 4 equals, we have to add this, negative 15. So our I sub 4 would be negative 15 all over negative 7. And upon computing that, that should be positive 2.143 amperes. So we already solved the I sub 1. I think we have I sub 1, we have I sub 2, and we have I sub 4. And finally, for I sub 3. And to solve for I sub 3, So for I sub 3, we have to use equation 3. Okay? So we have this negative I sub 2. So this is basically equation 3. So we have 2.5 plus I sub 3 minus 3 I sub 4 equals 0. So we have I sub 3, 3 I sub 4 minus 2.5. So I sub 3 would be 3 times I sub 4, which is 2.143 amperes minus 2.5 amperes. If we are going to solve for that, then that is 3.929 amperes. So our answer, I sub 1, would be negative 7.5 amperes. I sub 2, negative 2.5 amperes. I sub 3 is 3.929 amperes. I sub 4 is 2.143 amperes. So that's it, guys. I hope you enjoyed watching the four meshes of watching our solving four meshes for our super mesh. So if you learned something from this video, please don't forget to subscribe to my channel and please thumbs up this video and subscribe to my channel and share it with your engineering friends. So thanks so much for listening. God bless you.